Hello students, welcome back to the 11th video of this playlist. So in this video we will be solving question number 11. That is the last question from May 2024 P1 paper. So let's see what's the question number 11. That is the last question of this paper is about. So basically the concepts behind question number 11, it's from combinedly from trigonometry and graphs, transformations of graph. So you can say the concepts behind question number 11, it's discussed in chapter number 4, the last part of chapter number 4, that is transformation, and chapter number 6, that is trigonometric ratios, the trigonometric graphs, to be more specific. Okay, so in order to be able to solve this question number 11, you should have definitely know the concepts of transformation of graphs, and also you should have clear idea about the trigonometric graphs of sine theta, cos theta, and tan theta. Okay, so let's get started with question number 11. So at first you can see a figure 4. So a figure 4, this is the sketch of a curve C1. The equation of curve C1 is given as y equals to 12 sine x. So this is the graph of what? 12 sine x. Okay, where x is measured in radians. Okay, x is measured in radians, keep it in mind. The point P shown in figure 4. Where is point P? You can see a point P, the maximum point on this curve, the second maximum point. So point P is a maximum point on C1. Find the coordinates of P. We need to find out the coordinates of point P. So this is very straightforward question. So you can see that point P is basically the second maximum point on the curve 12 sine x, right? So 12 sine x, it is basically a transformed graph, right? So what type of transformation is this? 12 has been multiplied outside the function. That means it is vertical stretch by scale factor 12. That means all the y coordinates will get multiplied by 12. Now at the maximum point on the curve of sine x, we know that the value is what? The y value is maximum 1. So the y value at point P would be 12. So we got the y value, that is what? 12. And you can see that the point P, it's the second maximum point, right? Is the second maximum point. So since it is the second maximum point, so what we can say? Since it is the second maximum point, so consider in the graph of sine theta, in the graph of sine x, the first maximum occurs at where? Sine 0 radian is 0, sine pi over 2 radian, this is 1. So this is the first maximum point, right? So the first maximum, it's happening at where? It's happening at x equals to pi over 2, right? Okay, just hold a bit, it's having some issues. Okay, so for part A, the x value, the y value, we got what? The y value of point P is 12, nothing but 12, and the x value would be what? The first maximum is at pi over 2, and so the second point maximum would be just 2 pi later. So pi over 2, because we know that sine theta, the graph of sine theta is what? Symmetrical. It's periodic. After 2 pi radians, it repeats. So 2 pi plus pi over 2, that is what? So 2 plus half, that is what? 5 over 2 pi radians. So the x coordinate of point P is what? 5 pi over 2 radian. And that's the coordinates of point P. Done. Next, part B. For part B, what they have asked here, let's see, for part B, the curve C2, another curve C2 has equation y equals to 12 sine x plus k. 12 sine x plus k. So just try to figure out the transformations, like what are the transformations happening to the graph of sine x. 12 vertically stretched by 12 scale factor 12, and then plus k, this is outside the function. That means vertical translation towards the positive y-axis by k units. Okay, wait, not positive, I'm not specifying positive, it should be vertical translation by what? K units. It can be positive, it can be negative. We don't know exactly whether k is positive or negative. That's why it is unknown. Okay, so this is the transformation here happening. So what we need to do here is that given that the maximum value of y on C2 is what? 3. The maximum value of curve C2 is what? 3. Okay, maximum value is 3. Now let's consider one thing. In the graph of sine theta, where does the first maximum value occurs? Okay, before considering that, let's read the question B. Find the coordinates of the minimum point on C2. Find the coordinates of the minimum point on C2 which has the smallest positive x coordinate. Which has the smallest positive x coordinate. So we need to find out the coordinates of the minimum point on the curve C2 which has the smallest positive x coordinate. Okay, so before approaching this answer, we need to consider this fact. The maximum value of y on C2 is what? 3. So when would be the maximum value of C2 occur? When sin x is maximum. Sin x is maximum, that is 1, right? So that means when sin x is maximum, that is when sin x is 1, you will have the y value of C2, that is what? 3. That means 12 plus k equals to what? So we can write what? 12 plus k equals to what? 3. Since this is the maximum possible value, so you will get the value for k. This is what? 3 minus 12, that is negative 9. So we got the value for k. Now we can, it will be easier for us to find out the minimum point, the coordinates of the minimum point. So what would be the minimum point? Now consider when the minimum point on the curve C2 will occur. The minimum point will occur when the value of sin x is what? Minimum, that is negative 1, right? So that means k minus 12 is the minimum value. Okay, so k minus 12 is what? It's the y value of the minimum point, right? In part B they asked for the minimum point on this curve. So the minimum point is what? Minimum point is what? The y coordinate is what? What I said, negative 12, negative 9, that is negative 21. The value of k is negative 9 and sin x is negative 1 in the minimum point. So negative 12, negative 9, that is negative what? 21. So we got the y value. Now it's turn for the x value. Now consider the x value. What would be the x value? Look, which has the smallest positive x coordinate? Which has the smallest positive x coordinate? So for which smallest positive x coordinate the value of sin x is negative 1? Consider sin 0 radian is what? 0. Sin pi over 2 radian is what? 1. Sin pi radian is what? 0. And sin 3 pi over 2 radian is what? Negative 1. This is the smallest what? Positive x coordinate for which the value of sin x is what? Minimum. And if sin x is minimum, then we know that the curve C2 will be minimum. So we got the x coordinate what? 3 pi over 2 radian, and the y coordinate is what? Negative 21. That's it. Now part C. Okay, for part C, what they have asked here, let's see. The curve C2 has equation. Okay, the curve C2 has equation y equals to 12 sine x plus b. Just try to understand. Sine x plus b. 12 sine x plus b. That means it has vertical stretch by 12 scale factor 12, and at the same time it has horizontal translation by how much? How much units? B units. B units, right? We don't know exactly, or we know that b is a positive constant. Okay, we know that b is a positive constant. That means horizontal translation, it's happening what? Since b is positive along the horizontal axis, we know that always the opposite thing happens. So since b is positive, so that means they are moving the graph to the negative x-axis by b units. Fine. Okay, so given that pi over 4 the x coordinate and y coordinate is a, where a is a constant, is the minimum point on C3. It's a minimum point on C3 which has the smallest positive x coordinate. Okay, it is the minimum point on C3 which has the smallest positive x coordinate. So the question is, find the value of a. We need to find out the value of a. Okay, what is a there? A is basically the y coordinate, right? Y coordinate of what? Y coordinate of the minimum point. So this is very straightforward to find out the y value. How? You can see that this is what? Sine x plus b. That means the value of sine x plus b can be maximum 1, right? It can be maximum positive 1 and minimum what? Negative 1. Just I'm considering sine x plus b, right? So that means since C3 is the minimum point, that means it should be minimum, right? It should be what? Sine x plus b should be what? Negative 1, right? So if sine x plus b is negative 1, then what would be the y value? Which is negative 12. So the value of a is what? The value of a is here what? Negative 12. A is negative what? 12. Done. Okay, we got the value of a. Next, for part 2, what they have asked here. For part 2, they are asking to find the smallest possible value of b. Okay, this is challenging. Smallest possible value of b. How can we find out the smallest possible value of b? Okay, now consider what is b. Basically b is the units by which the translation is happening, right? Okay, so we already know the x coordinate of the what? Of the minimum point on C3, right? We already know the x coordinate of the minimum point on C3. This is the x coordinate, which is pi over 4, right? Okay, pi over 4. Now what we considered that the minimum point on C3 will be found when sine x plus b is equals to what? Negative 1, right? Right? Sine x plus b, it is equals to negative 1. Okay, let's consider that sine, for part 2, sine x plus b is equals to what? Negative 1. Then we will get the minimum point, right, on C3. So the x coordinate is already given, which is sine what? Pi over 4. Pi over 4 plus b, it is equals to what? Negative 1. So we know that since it is the minimum point, so if you do sine inverse negative 1, what you will get? Pi over 4 plus b. So sine inverse of negative 1 is what? You should consider the smallest positive x value, right? So sine inverse negative 1 is what? Sine 0 radian is 0, sine pi over 2 radian is 1, sine pi radian is 0, and sine 3 pi over 2 is what? Negative 1. So 3 pi over 2 is the smallest positive what? Value for what? X plus b. Fine. So we need the value for b. So what would be the value for b? The value for b would be 3 pi over 2. 3 pi over 2 minus what? Pi over 4. So 1.5 minus 0.25, that is what? 1.25, that is 5 over 4 pi radian. So the value for B is what? 5 pi over 4 radian. That's the answer for part 2 of question C from question number 11 May 2024 P1 paper. And that's all about, like, that's the end of this question. So I hope so you have understood the whole solution of the question of this P1 question. And if you have any inquiries or any confusion in any of the part of the lecture, in any of the videos of this playlist, feel free to write it on the comment box. Thank you for watching the video and keep connected. Fine.